The calculations in homework 10 here are quite tough, so if you're struggling with them, I'm not surprised. Really, if these were to appear in a GCSE examination, it's only going to be the students that are going to get in grades 8s and 9s that are going to get them. Having said that, I still think they're doable, and I will help you in this video with these calculations, so don't give up on them, because of course, you know, really students that do try with these homeworks usually get grades 7s, 8s, 9s at the end, so it's well worthwhile the effort. Okay, so you'll need a calculator, a scientific calculator, but I'll put that to one side at the moment. Let's start. What's the relative formula mass of each of these? Okay, so I'm not going to do this for you. I'll do a different one. I'll do, how about aluminium sulfate, Al2SO4 brackets 3 times. What's the relative formula mass, the MR of aluminium sulfate? Well, if we're going to do this, we have to be able to count atoms well. So the first thing is to write out what atoms we have. So I've got Al2, 2 aluminium, so that's aluminium plus aluminium. Now I've got brackets, and brackets are hard to deal with. So everything inside the brackets is multiplied by the number outside. Now I've got 2 elements inside the brackets here, sulfur and oxygen. Now there's no number after the sulfur, so there's an invisible number 1 there. So I've got 1 sulfur in the brackets multiplied by 3. So I've got 3 sulfurs, plus sulfur, plus sulfur, plus sulfur. It then says O4 in the brackets. Okay, and there's a 3 outside the brackets. So I need to multiply that 4 times 3. So 4 times 3 is 12, so 12 oxygens plus 12 oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And they are all the atoms in aluminium sulfate. So we then need to look at the relative atomic masses. The relative atomic mass of aluminium happens to be 27. I know that. You don't have to learn these. They're on the periodic table. Oxygen is 16 and sulfur is 32. So you could then substitute under each of these times you've written an atom, the relative atomic mass. So aluminium is 27, so I've written 27 under the aluminiums. Sulfur 32, plus 32, plus 32, plus 32. Now I'm not going to write plus 16 12 times. You can do that if you want to, and it's a bit slower. It was a lot slower. And when people do that, they very rarely get the wrong answer, if I'm honest. So if you're a bit weak with it, if you're a bit unsure in your maths, I'll say unsure rather than weak, then why not write it out 12 times, plus 16 12 times. But I'm just going to write plus 16 is the relative atomic mass of oxygen and multiplied by 12. I'm just going to write that. Right, so 27 and 27 is 54. 32 is 96. Well, 10 times 16 is 160, 2 times 16 is 32, so that's 192 plus 192. So if we add those up, then we will get the right answer. If we have brackets like this in the equation, it's essential we work out what's that sum first. That's why I've just done this extra stage here. So 54 and 96, 150 plus 192, that's going to be 342. So that's the answer to aluminium sulfate. That's not one of your homeworks, so I'm afraid you have to do those 4 on your own, but they're exactly the same way. Next question: how many moles how many moles of the following are present? 23 grams of ethanol. Well, I'm going to do, let me do a different one. I'm going to do 80 grams of magnesium oxide, MgO. Okay, to do this, you have to know this equation. Moles equals mass over formula mass. It's the most important formula in chemistry to learn. Okay, and you have to learn it. So the mass, we know what a mass is. A mass has a unit after it. So when you see a unit in the question, that is a mass. So that's going to be 80. The relative formula mass, well, that's what we were working out in question number 1 up here. So magnesium oxide, I've got 1 magnesium and 1 oxygen. Well, magnesium has an atomic mass of 24 and oxygen is 16. Okay, so we're just going to add 24 to 16 because there's just one of them. So 24 and 16 is 40. 80 divided by 40 is 2 moles. So that's my answer for 80 grams of magnesium oxide. You need to do the same for those. Right, now it starts getting much tougher. How many molecules of the following are present? 64 grams of oxygen. Okay, so we need another formula for that. And that is going to be number of molecules equals moles times the Avogadro constant. Okay, that's the formula we're going to use. Okay, now, just noticing this here, I haven't written the Avogadro constant in there. You're not expected to know it. The Avogadro constant is 6.02 times 10 to the 23. That will be given to you in the question, and by the time this homework is turned into your work, because I will have written that in, because I'm going to do it right after I've finished filming. So 6.02 times 10 to the 23, that's the Avogadro constant. Okay, so what we need to work out now then is the number of moles in each of these. Okay, so I'm not going to do those two. Let's say I'm going to do 22 grams of carbon dioxide, CO2. So I want to know how many molecules there are in 22 grams of carbon dioxide. So to do that, we need moles equals mass divided by formula mass. Okay, the mass is the grams again, so we know it's a mass because it's got a unit after it, 22 divided by, so I need the formula mass of carbon dioxide. Well, carbon has got an atomic mass of 12, and oxygen is 16, so it's going to be, that's going to be 12 plus 16 equals 44. So 22 divided by 44 equals 0.5 of a mole. So now I've worked that out, I come over to here and I put that half mole in there, 0.5 times the Avogadro constant, 6.02 times 10 to the 23. Okay, and the answer is going to be 3.01 times 10 to the 23, having just done that in my head. But you are going to have to put it into the calculator. So this is the real challenge here. Is getting this Avogadro constant into the calculator correctly. Most students fall down at that point. Okay, so 0.5 is easy, so we're going to put 0.5 in. Multiply is easy, that's the multiply button. 6.02 is easy, 6.02. And now the place people go wrong, they put multiply again. Don't press multiply here. Do not press multiply. We need times 10 to the x. Okay, that's that button there on the end of my pen. Let's move the calculator up so we can get it in shot. Times 10 to the x, that's that button there. Okay, it may be labelled something different on your calculator. It may even be in a different place on your calculator, but you need to find that button or that function. Ask your teacher if you're not sure. So that's the times 10, now the 23. Okay, and then we press equals. We get the answer 3.01 times 10 to the 23. That's the answer I've written down. Next question. How many moles of the following are present? Well, this question here now is identical to this question here. It's just more examples. Okay, that formula. Final question. What is the mass in grams of 6.02 times 10 to the 22 molecules of hydrogen chloride? Okay, for this question here, we're going to use the exact same formulae we used in this question. Okay, we just need to rearrange both of them. Okay, so we have been given the number of molecules, okay, and we know the Avogadro constant, so we need to calculate the number of moles, okay. So to do that, that's going to be number of molecules divided by the Avogadro constant. And that will tell us the number of moles. Once we've done that, we can rearrange the moles equals mass over MR equation to be mass equals moles times formula mass. Okay, and that will give us that answer. To give you an example of this one, I'm going to use carbon dioxide again. I used carbon dioxide in this example up here, didn't I? So carbon dioxide had a formula mass of 44. We worked that out there. Carbon dioxide is made of 1 carbon and 2 oxygens. So carbon has an atomic mass of 12 and oxygen has an atomic mass of 16. So we've got 2 16s there for the 2 16s. So the formula mass of carbon dioxide is 12. So let's say the question, I want to know the mass in grams of 1.204 times 10 to the 24 molecules of CO2, okay? So we've said the formula mass of CO2, the MR, we've said that already. The MR is 44 for that, so we can immediately put 44 down there. So we now need to calculate the number of moles present. We have this many molecules. Well, so that's going to be number of molecules divided by the Avogadro constant. So that's going to be 1.204 times 10 to the 24, because that's the number of molecules we've got in the question, divided by the Avogadro constant, which is given in the question, 6.02 times 10 to the 23, and I will write that in before this gets printed into your workbook. So by doing that, that will tell us how many moles we've got. So again, I'm just looking at that, I'm telling you the answer's 2 straight away, but we'll put it in the calculator because you need to practice putting these into the calculator. So 1.204, now the times, not multiply, times 10 to the x, times 10 to the x, 24, divided by 6.02, not times 10 to the x, 23 equals 2. Okay, so we've got the answer to there of that is 2 equals 2. So we're going to take that over to here now. Moles times MR, 2 times 44 is 88 grams. So if we start with 1.204 times 10 to the 24 molecules of carbon dioxide, you're starting with 88 grams of carbon dioxide. Next question, I've got an equation for you to balance. Ammonia is neutralised with sulfuric acid. This is essential, you know these basic formulae. Go back to homework 1 if you can't find it. Okay, but that's going to be, I'll do a word equation. You need to put the symbols of everything beneath it. It says ammonia is neutralised with sulfuric acid. So that's ammonia plus sulfuric acid, okay, in the production of ammonium sulfate. So we're going to have ammonium sulfate over there. And the formula of ammonium sulfate is given to you. There it is there, so that's an easy formula to write underneath that. Write me a balanced symbol equation. So correct formula first, please, and then balance it out. Next one, iron oxide has the formula Fe2O3. Use this to deduce the charge on the iron, the Fe ion. Well, why don't I do aluminium iodide? Aluminium iodide, and we want to work out the formula of the charge on the aluminium ion there. Well, to do that, we need to look at what it's bonded to. It's bonded to iodine. Okay, then we need to look at the periodic table and find iodine. Okay, iodine's here. That means it's in group 7. Okay, everything in group 7 has 7 electrons on the outer shell. So if it wants to form an ion, it's either got to lose 7 electrons or gain 1, where it goes for the less number, gaining 1. So everything here has got the formula minus. Everything in group 7 has got the formula minus. If it's in group 6, it'll be 2 minus. In group 5, it'll be 3 minus. That's the way the periodic table helps us with this. So this is I minus, and we've got 3 iodines. So I've got I minus once, I minus twice, I minus 3 times. So I've got 3 negative charges. Well, I've only got 1 aluminium, so that aluminium has to have 3 positive charges to balance out the 3 negative charges. Okay, here we've got 2 ions. So however many negative charges there are on the oxygen, the 3 oxygens, has got to be divided by 2 to get that one. Have a go. Give the electronic configurations of the ions formed when lithium reacts with oxygen. Well, I'm not going to do that. I'm going to do magnesium reacting with chlorine. So magnesium reacting with chlorine has the formula MgCl2. Okay, so we can figure that out by saying magnesium is here in group 2 of the periodic table, so that means everything in this group has got 2 electrons on the outer shell, therefore it forms the 2+ ion, so that's Mg2+. Okay, and chlorine is here in group 7, so that has the formula Cl-, because everything here has got 7 electrons and needs 1 more, so that's going to be Cl-. So the electronic configurations. Magnesium has got 12 protons in the nucleus. That means ordinarily Mg with 12 would have an electronic configuration of 2, 8, 2. But we're saying it's a 2+ ion, so the electronic configuration of the Mg2+ ion will be Mg2+. It will be 2, and it's lost those 2 electrons to become the 2+ ion, so it's just going to be 2, 8. And likewise, chlorine. If we look on chlorine on the periodic table, chlorine has got an atomic number of 17. So we can draw chlorine out. Let's do it above. Chlorine 17. So that will be 2, 8, 7. Okay, but it's a Cl- ion. So it's become negatively charged by gaining an extra electron. So the Cl- ion will have the electronic configuration of 2, 8, 8. When it becomes negative, it gains 1. So work out the charges on the ions. Okay, look at the atomic numbers, and then write out the electronic configurations of the ions. Okay, good luck.